So, today we're going to look at similar figures. I just want to make sure that before we cover this topic, we rehash of what we've already learned in 2C, which was about congruency and also congruent triangles. Last week, we learned about this word congruency, and we saw that the definition involved that they had to have, in order for two objects to be congruent, they had to be exactly the same size and shape. So we could then have a definition of that, of what congruency is. Similar figures is, funnily enough, similar to congruency, but it lacks one of those conditions, in that similar figures have the same shape but are of different size. Okay, same shape, different size. So that means, how can something be the same shape but different size? Well, the angles have to be equal of the shape. All the inner angle, inside angles have to be the same, and the corresponding sides have to not necessarily not be the same because they're different sizes, but are in the same proportion or ratio. So today we're going to look into, because we're looking at this specific part of talking about sides not necessarily being the same but having the same proportion, we'll be looking at something called the scale factor. And so, just before we start this, I do want us to make sure that we understand the symbols that we have to use. Before, when we were talking about congruency, we used this symbol, 1, 2, 3, to define that triangle ABC is congruent to DEF. That's congruent, okay? Whereas if a triangle or any other shape is similar, not congruent, we use a different symbol. Here we can use the vertical three lines and go like this. So this, just to make sure we're clear, this symbol is for similar, and this symbol is for congruent. Now, what we're going to do from here is we're going to find out how we then apply that to a question such as this. Let's take a look at this question here. We have write a similarity statement for the two shapes. So basically, we've already been given that these two shapes are similar. We don't have to prove it just yet. It's telling us it is. So we had to write the statement. So this is not a triangle. This is actually a quadrilateral. And so what we're going to do is we're not going to draw that symbol. We're simply going to write A, B, C, D, which is this shape right here, A, B, C, D. Okay, this shape is similar to E, F, G, H. And that's how you complete that question. We've written the similarity statement now for these two shapes. Let's take a look at B. Complete the following. This is implying, so you might not understand what's going on here yet. I'll just write down the question so that you can see what's happening here. Okay. EH, which is this. So EH, let's highlight it so we can see it. EH right here is equal, EH over something, we don't know what that something is equal to FG over something. Now, because it's a similar shape, these two shapes are similar, it means that the sides might be different to one another, but they are actually of the same proportion, same ratio. So all we have to do is take this EH over here and find the similar side on the other shape. So I'm looking at this shape right now, and I'm going, well, which side is EH, or which side is similar to EH? In this case, I'm looking at this quadrilateral, and I'm seeing that this is the longest side. So I'm looking for the longest side over here, and I see this, and I'm going, that's it. That's got to be the similar side. So EH over AD, right, AD, EH over AD must equal to, once again, looking at this, so I have the FG over here, and I'm going, that's the shorter side, and it meets the diagonal, so it's got to be this one, right here. So EFG over BC. And there you go. We've now written a proportion statement where it's actually showing by going to the two similar sides, we're saying that these two will actually be equal to each other because the proportion or the ratio are the same in similar figures. We'll do question C, and you can see more of what's going on when we do question C. It says find the scale factor. So write scale factor. Okay, scale factor is once again, we're doing this thing again. We're looking at this or we're looking at this, and we can choose any two sides we want. To find the scale factor, we're going to need to find two sides which both have a value. Okay, because some of these sides don't have lengths written next to it or an unknown length. Some of them have an unknown length. I want known lengths. So I'm looking at the first thing that catches my eye is this side right here, because that has the 5 centimeters. And that side is also present on the similar side here on this shape, which has the 2 centimeters. So all I have to do is go EF over AB, which is equal to 5 over 2, or even we could even write 2.5. So this is the scale factor, okay? So if we're going from the smaller shape to the bigger shape, I multiply by the scale factor to find the unknown lengths. If I'm going from the larger shape to the smaller shape, I'm dividing with the scale factor right here in order to find the proper values. So what does that mean? Look at question D with me. It says find the value of x. So I'm looking for this value. I don't know what it is, but I can find it now because I have the scale factor. So all I have to do to find the value of x is find the similar side of x. So before EH, we knew that the similar side is AD, okay? This side right here, okay? AD is 3 centimeters, and it's going to be bigger. You can see that x is going to be bigger than 3, so I'm multiplying by the scale factor, which I found over here. Okay, so this becomes 3 times 2.5, which is 7.5 centimeters. That's how you find x. And finally, the final one, they've added this question. Hopefully, you can see why, because they want us to see that sometimes you don't necessarily always multiply by the scale factor. Sometimes you might have to divide depending on which way you're going. I'm looking for y, which is over here. Let me just highlight it. This is y. Okay, I'm looking for the similar side. The similar side is that one right here. Okay, so what I'll do is I go, okay, well that's the longer side, 7, and I'm going from here to here, which is the shorter side. So now I'm going to divide by the scale factor that I found before, and I go 7 divided by 2.5, whoops, is equal to, okay, and then that's how I approach that question. Of course, I'll have to get the answer for myself. 2.8 is the answer. So here, of course, you could have just put that in your calculator, but I didn't have one. And that is how you approach these questions. So give it a go, see how you go. What you can do is you can go to the checkpoint or just go straight to the textbook excerpt and start doing these questions. All the best.